an introduction to Flutter this evening. So thanks for everyone for coming along. Should be good. Just a quick overview of the upcoming events. So we've got an advanced look, as we've already kind of mentioned already, happening next week. So that'll be kind of following on from this evening's workshop, picking up on anything that came out of potentially today's workshop. Any questions, anything that we can't cover, we'll be going over in next week's session and also just picking up from today's session. Following week, May 21st, we've got data science and practice. Got a few data scientists coming along to tell us what they use data science for in their day-to-day. And then Kev, I think you're in chat or in the video somewhere around here, is doing a foray into the 8-bit adventure world with fantasy consoles. You got me peaked, my interest peaked for sure. I've been working with a bike simulator of some description over the last few weeks. It's been interesting to watch. Virtual Social Club tomorrow night, 5:30. Goes for a couple of hours. Turn up whenever you wish. Join us, say hello. We played some games of Fibbage last week. It was pretty good fun, and there was even some music, I think. A quick mention of also tomorrow evening, after Virtual Social Club, I think it's at 8 PM, a little bit later this week, Roll-Ups online pub quiz. Highly recommended. We've been for the last 2 of those, and they've been really good. Quick mention of the NorDev Discord. A lot of conversation going on there, which is why we're doing a lot of focus on Flutter this last few weeks, sorry. And then, like I say, I'm just going to move on swiftly to Tom and get out of the way. So yeah, thanks everyone for turning up. And without further ado, I'm going to hit the stop share button as soon as I can find it. There it is. Awesome.
Cool. Thank you, Alex. I'll try to start my screen sharing. And let me know when everyone can see my screen. Can people see?
Not yet. Oh, no.
Oh. Yeah?
No, not yet.
No, I can't see a screen share yet, I'm afraid.
It's not gone well.
Ah, there we go.
There we are. We're there?
Yep, we're there.
Awesome. Cool. Brilliant. So cool. Thank you everyone for coming tonight. This is an introduction to Flutter. And I'm just going to share with you the itinerary for tonight's talk. So firstly, we're going to go through what Flutter is and why it's different to other cross-platform frameworks. Then we'll look at creating a new project, running it on a simulator, and also taking a quick look at what hot restart and hot reload is. A couple of these bits were covered last week by Phil and Paul. I'm just going to go over them just quickly for the general flow of the talk. Then we'll take a look at what widgets are. Widgets are Flutter's UI components. And we'll take a look at some basic ones which we're going to be using, some multi-child widgets, and we'll also look at what some of the debug tools that Flutter provides for us, one of them being the widget inspector. After that, we'll take a look at navigating between screens, because no apps nowadays really have one screen. It's quite common to have multiple, so we'll look at navigating between them. And if we have time, then we'll cover showing alerts and modals as well. If not, that's something that I'll cover next week. Then we'll take a look at dependency and package management, how Flutter handles that. This we will definitely cover this week. And then finally, we'll take a look at what data persistence options we have available to us in Flutter. And we'll also do a very quick implementation of a basic NoSQL data store. So without further ado, I'm going to jump in to what is Flutter and why is it different? If you've been to any of my other talks, these next couple of slides might look familiar. But firstly, Flutter is Google's cross-platform UI toolkit. There's several others, as I'm sure you all know, such as React Native by Facebook, Cordova or PhoneGap from Apache, and some Xamarin variants from Microsoft. But Flutter is Google's take. Flutter, at present, produces native iOS and Android apps. It does also do others, and I'll touch on that in a moment, but right now, stably, it produces native iOS and Android apps. It doesn't do hybrid apps like Cordova does. The output is a native binary. It's written in Dart, and Dart is not a massively common language, but its syntax and the way you use it is actually not too dissimilar to things like Java and C#, maybe with a hint of JavaScript as well. And what's cool about Dart is that it can be just-in-time interpreted, but also ahead of time compiled. So when it's ahead of time compiled, it has native performance because the Dart code has been compiled down to machine code running right on hardware. There's no interpreting. But when you're debugging, Dart can run in just in time, and that allows us to use things such as hot reload and hot restart. So that concept is basically saving your source code and seeing the changes reflected instantly in your current debug session without having to stop debugging and recompiling, which can be a very lengthy process. And it's a pain for mobile devs, really. Flutter is built to be platform agnostic. While I've mentioned that, yes, it currently produces native iOS and Android apps, it's built to be platform agnostic, and it can also run on the web, Mac, Windows, Linux. People have also managed to get it running on Raspberry Pis, so it's even venturing into embedded systems. It's also running on what Google refers to as ambient devices, such as the Nest Hub Max. And I think it was also running on the Google Home Hub for quite a while as well. Although I've lost track of what they're calling it at the moment and when the name changed, either the Nest Hub or the Google Home Hub. So cool. Why is it different? Now, Flutter is different to React Native, Cordova, Xamarin. And to demonstrate how it's different, we need to look at the technology stack that Flutter uses. So firstly, Flutter is first and foremost the UI framework, really, in the stack. Flutter is an SDK that it's written in Dart, and you also write Dart's code to use it. Flutter then uses Skier, which is a 2D graphics library written in C++ to do all of its graphics rendering. Skier, you actually are using stuff that uses Skier every day. Skier is the render engine for Google Chrome, also quite a lot of Android, Chrome OS, Firefox, and Firefox OS as well when that was a thing. So yeah, it's widely used, very performant. Yeah. So I've put these three in a box because it represents the core Flutter stack. Wherever Flutter goes, this stack kind of goes. So wherever this stack can run, Flutter can run. These next two layers, I've got two platforms down here, but these layers represent the graphics API and the platforms that they run on. So what's going on here is Skier is then using OpenGL for its graphics API to do the rendering. And OpenGL, as I'm sure a lot of you know, runs in quite a lot of places and on quite a lot of operating systems. I'll come back to this as well. But because these two layers are outside of the core Flutter technology stack, they can all be changed. So the platform here can be changed to macOS, for example, or even the web. And this graphics API can also be changed to Metal, for example. In fact, yesterday, Flutter released their latest stable version, and it now includes Metal support. Metal is Apple's graphics API, which runs on iOS and Mac. And Flutter, when using Metal, provides up to 50% more efficient usage. That's not to say that when it was using OpenGL by default, it was bad. It was absolutely cracking, but using Metal, it's even better. So that's what a typical Flutter technology stack looks like. I'm going to compare that to what typical native stacks look like. So this column here is iOS, and this column here is Android. So at the top, iOS and Android use two different UI frameworks. iOS uses UIKit, and Android uses can find a better name for them, Android views. Then the programming languages you use are Swift or Objective-C, Kotlin or Java. Then the graphics APIs, sorry, the renderers are then Core Graphics and Skia, respectively. The graphics APIs are then Metal and it's mostly Vulkan now on Android, respectively. And then obviously these two are the two different platforms. When you throw React Native into the mix, React Native is a mostly JavaScript framework, and that sits on top of your native apps. So the framework is in JavaScript, and it uses a JavaScript bridge to communicate with the native platform. And because it uses this JavaScript bridge, and JavaScript in these instances isn't compiled, it's still interpreted, this is significantly slower than ahead of time compiled code. And when JavaScript is trying to orchestrate how different UI components should appear and where they should be placed and that kind of stuff, it can lead to some kind of jerky performance. Don't get me wrong, it is still pretty good in terms of performance, but it's quite easy to start getting to a state where you're not seeing as performant UIs. Further to this, if you see here, it's iOS and Android respectively are using two different UI frameworks, UI kits and Android views. When a framework, for example, React Native or something similar, when you say, I want a button on my screen, you're going to get a UI kit looking button and then an Android looking button. There's ways that this is kind of prevented out of the box, but you do hit limits because not all of the time do components in UI kits and Android views share the same different properties that you can change, and they do render ever so slightly differently. So you can actually spend quite a lot of time fighting with these frameworks to try and get things to render just right. Much like how in the web we fight with, well, things look fine in Chrome, but going over to Internet Explorer, they don't quite look right, or even in Firefox for some circumstances. Similar kind of thing here. But because Flutter, it uses the same UI framework, render engine, no matter what platform it's running on, the UIs are guaranteed to look the same. So when you specify the type of button you want in Flutter, it will look the exact same on Android, iOS, the web, Mac, wherever it's running. And that's really cool. You might be wondering, hold on a sec, this goes against the different platforms' design paradigms. But actually more and more companies that are making apps are focusing more on their brand rather than trying to make their brand fit with the platforms. Facebook is a good example. Facebook Messenger, Instagram, they're all apps which, for the most minute things, do use the native platform UI components. But for the most part, they don't. They're focusing more on what their brand components are. So that's why you don't necessarily need to worry that things will render exactly the same, whether they're on Android or iOS. So I'm now going to just show you a few UI components which Flutter gives us out of the box to get very Android-looking apps and very iOS-looking apps. In Android, the typical design library is called Material, and in iOS, it's referred to as Cupertino. So Flutter provides us with loads of different widgets, and I haven't said already, widgets are Flutter's UI components. These are all ones out of the box, which, if I didn't tell you these Cupertino ones were built in Flutter, would you have any idea that they were built in anything other than native? They look exactly the same, they animate exactly the same, they perform in exactly the same way. So if you wanted to, you can get very distinct Material looking apps and very distinct iOS looking apps if you really wanted to. Cool, so I've covered a bit about how Flutter works and why it's different and touched on what their UI components are. But now we're going to dive in and create a new project, run it on the simulator and demonstrate hot reload and hot restart. Before I do, does anyone have any questions at this stage? I'll stop and pause every now and then for questions. If you do have questions as we're going, feel free to ask or stick something in the comments.
I have a question.
Yeah.
So UI, you can make it look native to iOS and Android. Is that from the same code?
Yes, you can use the same code. So for some, sorry, let me just slow that back up.
Sorry.
For some things such as alert dialogues.
Yeah.
Over here, there are circumstances where you do need to check. Yeah, if you wanted a material-looking dialogue and an iOS-looking dialogue on their respective platforms, at runtime, you can do a check to see, is this running on iOS? If so, use the iOS variant. If not, it's running on Android, then use the material variant. Right. Those are really the only cases that we found. The company I work for, we've done 3 production level Flutter apps, and the only places we found really are when it comes to dialogues that we do want to use the UI components that feel right for the platform. So that's the only time that we really need to put in checks.
Okay, thanks.
That's okay. It is more common to see material-looking UI components on iOS than it is iOS-looking components on Android. With Flutter, you can absolutely interchange. You can use some material, some Cupertino, and vice versa. You might not necessarily want to, but because Flutter's UI system is so flexible, and I'll demonstrate that in a moment, you can put stuff anywhere. I'm not saying you should, but it's flexible enough that you can. Cool. So my machine is already set up. There's some very easy setup instructions as followed by Phil and Paul last week. So yeah, you can just choose which platform you're running on, and it tells you just how to install it with some very easy steps to the point that you eventually get running. I'm going to be using Visual Studio Code for this and an iOS simulator. You can also just use the command line and then whatever code editor you want. You can use an Android emulator. You can even use physical devices, but we find that iOS simulators, of course, this is only available on Mac, in combination with Visual Studio Code, just makes for a really lightweight development environment. So cool, I'm in Visual Studio Code now, and I'm going to go to the command palette, and I'm going to type Flutter, and it's going to tell me, oh, look, you can create a new project. So by doing this, it then just asks me a couple of questions. So what name do you want to give your project? Flutter dev 2020, I'm going to call that live because I've already done a test run through. It'll then ask you where you want to create this project. So you can just choose your location. And this then, in the background, does actually just run the Flutter command line tool in order to create your Flutter project. So you can see the command it's outputting down here. So it's just going to do that. While it's doing that, let's talk through what has actually been produced for us. So this is everything that's involved in a Flutter project. Let's go through folder by folder. So firstly, these .dart tool and .idea folders, you don't need to worry, those aren't things you touch. That's just generated based on what IDE you're using. So the next folder down, Android, this is literally an Android project. It's kind of more so a shell just to allow Flutter to launch and run and then use Android APIs if your app needs to. So if you dive down here, you do then see that there is a Kotlin file. So if anyone's familiar with Android development, you know that it uses activities. The main activity just inherits from a Flutter activity. And somewhere deep down in this is where it launches the Flutter part of the app. So yeah, you've also got things like your manifests, Gradle files, that kind of stuff. So yeah, if you do need to do any native code, sorry, yeah, I also forgot to mention, Flutter runs side and side with native, and it can communicate with native APIs if it needs to, if you want to. And quite typically it does, but again, quite typically, as I'll show you with dependencies later, loads of people have already written pretty much everything you might need to do anyway, which is really cool. Much the same here with iOS. This is just a basic iOS iOS shell, which again just instantiates the Flutter part of our app. And you can actually go ahead and open these in Android Studio and in Xcode respectively, if you do need to go and fiddle around with names or provisioning profiles and certificates, that kind of stuff. Lib, this is where the Flutter parts of our app lives. This is where we write all of the Flutter code. And I said earlier, we use Dart to write Flutter apps with. I'll come back to that. These last two folders, test and web. Test is just this is where your unit tests and widget tests live. Here's a kind of canary widget test. That's out of the scope of this talk, so I'm just going to delete it. Web is much like iOS and Android, but I'm going to delete that and come back to that later. Lastly, the only other important thing here is this pubspec.yaml file. This is kind of like the manifest for your Flutter project. You can liken this to a CS proj or a package JSON in Node and C#. But yeah, so you give things like, this is where you do versioning for your app. This is where you specify your SDK constraints, stick things like dependencies. And then you can also specify other assets like images, icons, and then fonts down here as well. But yeah, I'm not going to touch on assets and fonts in this example, but we will come back and look at dependencies. So cool. I'm going to start this running and then talk you through short amounts of this. Yeah, in Visual Studio Code, down here, it asks you what device you want to run on, and it shows you ones which are currently running. So I've got 3 running here, or you can start others. I'm just going to select this iPhone 8, and then I can go to run and start debugging straight in Visual Studio Code, and this will start running the app. So let's quickly look at what has been produced for us. So this main.dart file is the entry point for the Flutter and Dart parts of our app. So Flutter uses Dart, therefore we have a Dart entry point. Much like with other languages, there is a main method, which is the entry point to Dart. This then calls run app, which basically attaches the Flutter app to the appropriate place in an Android or iOS environment or web environment. And we're saying we're going to run the my app. And that's just below. There isn't a lot that is special about this my app class at the moment. So Flutter uses widgets for its UI components, and absolutely everything in Flutter is a widget, which is really cool because it means it's incredibly flexible. So my app extends from stateless widgets. I'm not going to touch on stateless and stateful widgets in this, but there's even less time now, and there's quite a lot of other cool stuff that I want to show you. But yeah, so my app is what you're seeing here. This is this entire region. It produces a load of comments for us, which we don't need, so I'm going to talk you through some of them. Each widget has a build method, and that returns another widget, which returns another widget, and another widget, so on and so on, right down to a very deep level, which I think is element. Even I've not had to go down as far as writing my own elements, just because everything high level which Flutter exposes to us using widgets has been more than enough for what we need. So material app is a widget, and this just contains some basic properties such as a title and theme. Theme is where we can change global kind of styles for our app, such as color. I've just hit save there, and you've instantly see the changes reflected in the app over here. So that's hot reload working for us. Just going to revert that, and it's going to change back. We can also specify some text themes on here if we want. And yeah, there's loads of different theme style type things. If we hover over here, we can see there's loads. Then the app needs a home screen. You can think of this as like your main activity on Android or your initial view controller on iOS. And we're saying that this is going to be my home page. I'm actually going to come and delete this in a sec when we get going, but just to talk you through it. My homepage is also a widget. It's a stateful widget, which is slightly different to stateless, but again, out of the scope of this talk. This home is just expecting a widget, so you can stick pretty much anything here, and I'll demonstrate that again shortly. If we look at what's been produced in this app over here, sorry, is this big enough for people? I'll make it slightly bigger as well. Big simulator. It's just a very simple app with a button, floating action button, which when you press it, increments this counter over here. That's all nice. So I'm just going to skim over some of this because again, it's out of scope. We're getting to the part where it looks familiar again. There's another build method which is returning more widgets. I'm just going to delete more of this. So this, my homepage widget, is using a scaffold, and scaffold is a special type of widget because a scaffold typically represents a screen in your app. You can liken a widget which returns a scaffold as a activity in Android or a view controller in iOS. That's kind of where they're most similar. But yeah, you would use scaffold for overall screens. And it's got things on here such as an app bar, which is what we see up here. Body, again, that just expects a widget, so it doesn't really care what you stick in it, but it expects something. And in here we've got a center widget, which doesn't draw pixels directly to the screen. It just alters how its child is drawn to the screen. We then give a column to center. So yeah, you can kind of see here, Flutter is using a tree-like approach. I'm going to just quickly demonstrate that in a tree here. You start off with a material app, which has a scaffold, and the scaffold has an app bar, which has a body. Sorry, and the scaffold also has a body and has a center and has a text. So realistically, this tree is going to be quite a lot bigger. And Flutter also adds in some other stuff which you don't necessarily see. So things like material apps and scaffolds, but it uses a tree-like approach. Also, this slide might actually be useful to visualize where widgets are. When I say everything is a widget, this highlighted area region here represents the overall app. And sorry, everything that's circled here is a widget. Then down to a screen level, then down to an app bar, then text, the body, the text here again, and center as well, which centers the text in its region. So because of the tree-like nature and the kind of nestable stuff going on here, it looks a little kind of messy right now. When we start doing it ourselves, it'll look a bit neater. These can get quite big and you can get quite deep down. Of course, there's loads of ways that you can avoid that and loads of ways that you should use to avoid that. But yeah, so we've got some text here saying you have pushed the button this many times, which corresponds to this text here. To demonstrate hot reload in action again, I'm fairly sure Phil did this last week as well, but if we change the text to pressed, you can see it's been reflected here straight away. What you probably have also noticed is that this 6 has stayed the same. It hasn't completely lost the state of our app just yet. It's remembered that this button has been pressed 6 times. If we wanted to completely reset that and completely restart the app, we can press this button up here, and this does hot restart. And this completely restarts the Flutter parts of our app. So the entry point gets rerun, everything gets rebuilt and reattached. And that's really cool because we don't have to stop debugging and recompile, which takes quite a lot of time. We can just hot restart or hot reload and see changes reflected. So it dramatically improves development time, which is really awesome. Cool. So I've spoken a little bit about widgets. Before I dive on to showing you what UI we're going to be building up for this, does anyone have any questions again at this stage? I also just realised that I can't see it.
One question in chat. So somebody asking, can you turn the auto-generated closing comments off?
Auto-generated closing comments off. So yeah, I'm guessing they're talking about these. If I'm honest, it's not been something that has bothered me, so I haven't looked as to whether you can. I'm almost certain you probably can, but yeah, I've not found it an issue. It's not comments which is added. This comment here is a literal comment, and that was generated as part of the Flutter create command. But these, they do actually come in handy when you do start to get. I'm not saying you should ever have a huge tree. When you start to get, because there are all of a sudden quite a lot of brackets, commas, this kind of stuff, they do come in handy. So I've not actually found a reason to go and look as to whether you can turn them off, but I'm absolutely sure you can.
And then a second question from Philip. Do I need to learn Dart to use Flutter? As in, do I need to go away and completely learn Dart before approaching Flutter?
That depends. That depends on on whether you know other languages that are similar or have similar syntaxes. Dart in its rawest form is quite similar to C# or Java. Right now, this still looks very similar. You can specify properties, string. You can specify constructors. You can specify methods. There are some things which if you're coming from things like Java or C#, will throw you off straight away. I'm not going to lie there. So here, this method by default in Dart is actually public. There aren't public or private access modifier keywords. Private and public access is denoted by a underscore prefix to a property or method, or even a constructor. If you have an underscore, this is now private to this class. Without it, it is public. So things like that can throw you slightly off. There's also some other things, other Dart-specific things which Flutter makes really great use of. So in a typical Java or C# constructor, you might have a string, my string here. You would then typically go this dot my string equals my string. That's perfectly fine, that's perfectly valid. But in Dart, you can actually completely do away with this and reference this dot my string, and there is now a constructor ready for us, which just takes in my string and assigns it to that, which is kind of cool.
That's very nice.
Yeah. It also, and Flutter makes very heavy use of this, named parameters. So this is still a valid class.
Before you move on.
Oh yeah.
If my string in the class is private, if the member is private and it's got the underscore,
mm-hmm.
Can it still be matched from the parameter in my class like that?
It can, yes.
Oh, yeah, do it like that. Okay.
Yeah. What I'm about to do is not valid. So let me just undo that. So Flutter makes heavy use of named parameters. And named parameters, you can specify named parameters in the constructor or in a method by just wrapping them in codebases. You can even do others. So while I've referenced the class member, I can even do others that aren't my string 2, and then start doing stuff with my string 2 here. This is also a valid constructor. But with named parameters, you can't use a private member like this. That's invalid. But you can use public ones. In a non-named constructor or method call, you can do this dot my string. There. So it's those kind of little things which can throw you off if you're not familiar with it. So, oh, and also something else which you've probably not seen. There's no new keywords. You can absolutely use them, new, but Dart doesn't necessarily need them. There are reasons for that. One of them is compiler performance. If you specified properties as final, this is definitely going off on a tangent. But if you specify, if a class has everything final, you can make the constructor a constant. And then you can use this constant constructor with, if everything else is going to be constant, and that improves compile time. So it becomes a compile time constant, which just adds a bit more performance. But otherwise, the new keyword is not needed. So what we are seeing here, everywhere, each of these are constructors. So I can stick new here if I want. It's just not needed. And Dart will also work out whether it needs to use, where it can improve compile time performance by using constants or not. So yeah, and then these are all named parameters as well. So Flutter makes heavy use of not using the new keyword and using named parameters. One exception you can see here is text. It does just expect the data, the string. Cool. Right, so let's now move on. I'm now going to show you what we're going to be, the UI that we're going to be constructing. There's a website called UpLabs, which is a really cool website. It has loads of different app designs on. And ages ago, when year and a half ago, when I started exploring Flutter, I found someone on here called Nicola Baldo, and she had some really cool designs. And I asked if I can construct some of them, and she said, "Yeah, go for it." So yeah, we're going to be constructing parts of this design here. I've already downloaded. I say downloaded. I've already taken this image. If I was actually going to be building a design pixel perfect, it would typically be handed over by a designer using a tool such as Zeppelin or that. There's another one I can't quite remember, where I can click on the text and see the exact font, sizing, all of this kind of stuff, color inspections, spacing and stuff. So when we go through this, I've done it mostly by eye, because also the size of this screen isn't a proper iPhone size screen, so I can't just get the size of this and that'll be fine. It's actually not quite right. Yeah, so that's what we're going to be building up. We're mostly going to be building up this component here. So yeah, let's go ahead and start that. Firstly, I'm just going to neaten up this code bit, or just get rid of some of the code we don't need. I'm firstly going to create a screens folder and also a components folder. I'm going to delete this my homepage class because I don't want to use it. And instead, we're going to create a home screen class here. In Visual Studio Code, there's a really neat shortcut or snippet you can use to create a new widget straight away. Typing ST gives you the choice of what kind of widget you want to make. Again, I'm still going to use stateful, and I'm going to call it home screen. It doesn't automatically do the imports for you, but you can just use the light bulb and imports. And because this is a screen, I'm going to make sure it returns a scaffold. And so we can see that there is a screen there. If we just used this, there'd be nothing on the screen, it would be blank. So I'm just going to add an app bar in quickly. And I'm just going to replace this the home page for our app to home screen. So Visual Studio Code is going to automatically add the relevant imports for me. Cool, so I've hit save and that has been reflected. Again, that's pretty cool. I've just removed a screen and added one in and it's changed automatically, no need to recompile. This debug banner up here, don't worry, this doesn't get shown in a released built app. If it's really bugging you, you can turn it off by using this property on your app and it goes away. So I will turn it off for us. Okay, cool. So the next thing we want to do is start building this up. So this row here, so yeah, the context of this app is like a to-do list. And this component here is very much a component. It's kind of like a task row. So I'm going to go and create a task row component. And I'm just going to use the shortcuts again and call it task row. And it's fine to return a container for now. So I now want to start referencing it from my home screen. So I'm going to use the body. And actually, you know what? To demonstrate that pretty much anything can go in body, I can just stick some text here. and that's placed it there. I can stick a, what are the useful widgets? Are there? Well, sorry, there's tons of useful widgets. There's even a basic just Flutter logo for the sake of it widget that can go there. You can even stick another scaffold which has another app bar here, if you wanted to. You've got app bars and app bar, scaffolds and scaffolds. So yeah, that's really cool. Something else which actually also adds quite a lot of value quite quick is adding a navigation drawer. So straight away, you've now got a slidable navigation drawer, like really quick with like hardly any code. Something else I do just also want to point out. Actually, I probably shouldn't have said that, because over screen share, you're probably not noticing that it isn't quite 60 frames a second anyway. Because this is running on a simulator, simulators aren't very graphically performant, but when this is running on a device, and particularly in release mode, you cannot tell that this wasn't written using native, unless you really tried. Back to the problem in hand. We now want to use our task row. But when we come and take a look at this, we can see there's task rows on top of task rows on top of task rows. So I'm going to show you a widget, which is very useful, and we're going to use quite a bit, called column. Column is a special widget because it doesn't just take a single child widget. It can take multiple children, all of them widgets again. So we can have text here saying hello, and then small text here saying world, and it's now placed these widgets on top of each other, which is really cool. So for the purpose of building up a couple of these, we're going to use that. So inside our column, we're going to reference our task row components, and it's automatically done the import for us. So just so you can follow again, main is the entry point, and that is running our app. And the app has the home screen set to our home screen widgets, and we're using the task row component. You cannot see the task row component yet because it's not actually drawing anything. Container is a basic widget. You can liken a container to a div, for example. When it's got no starting point or nothing inside it, it draws nothing. Its size is 0 by 0. It doesn't have a color. Nothing. So also the other design handover tool, which is quite commonly used, is called InVision. That's another one which allows for design inspection to get absolute kind of sizes of text, spacing, this kind of stuff. But cool. So the first thing I'm going to do to demonstrate some drawing to the screen is give this container a color. And because I've imported the material up here, I have access to quite a few colors just out of the box already. That hasn't done what I expected it to do. Let's also give it a height of 140 units. There we go, that's better. Giving it a height of 140 units. These values are density independent units. So, ages ago when there was only really one screen density, this would correlate to 1 pixel. But then you start getting screen resolutions which are, twice the density, 3 times the density, etc. So one on a screen size which is on a screen where the screen is twice the density, 1 pixel corresponds to 2 in each axis. So if it's a width and height of 1, on a screen density which is 2, it produces 4 pixels. But that's something that we don't need to worry about. We're just able to use it, and it's all nice. So let's focus on just the layout parts first. We've got some text here. We've got some more text down here, and then we've also got a load of other widgets. If you look at how I've highlighted these, I've demonstrated that there are 3 distinct levels to this task row, and they're all aligned vertically on top of each other. So we're going to use a column again as the child to this container. children. And inside it, we've got some text. So let's place some text in here. We've got some more text, and what does that say? Update the logo. And then lastly, this is, because these are all on the kind of same level vertically, we need some way of aligning these horizontally. Can anyone guess what widget we might want to use to align widgets horizontally?
Please tell me it's the column widget, which is currently doing things in rows.
Okay, it is. Okay, I think I understand that there. Columns align widgets in. Okay, I can see how. I've never actually thought of it in that way before. Columns align widgets on top of each other in the y-axis. Rows. Sorry?
You're kidding.
Right. I'm not kidding. I must admit, I've never kind of really picked up on that thing before. No one's thrown that curveball my way. Rows align things horizontally. Columns, take it up with the Flutter team. But yeah, so text, row. The texts are going to be vertical, and the row is going to align its children when we give it some children horizontally. So tell you what, let's give this just some basic text. Hello, and then text. World. Awesome. So aligned vertically, even though these two parts are two different widgets, because they're in a row, they are aligned horizontally. If that's really bothering you, Alex, columns and rows actually just inherit from a flex.
No, it totally doesn't bother me at all. It's just quite funny that I genuinely thought you were going to put some kind of property on column that made it lay out as a column. But I'm just a web dev, so I guess that's...
Sure. Okay. Well, yeah, columns and rows are actually just inherited from flex. Sorry, they just return flex widgets with the direction property set. So I've changed that to a flex with a direction of vertical, and there's been no visual change because actually under the hood, it's doing the exact same thing anyway. I'll change this to horizontal.
I can deal with that.
Okay, yeah, cool.
Yeah, that's good. The vertical and the horizontal make sense as well.
Cool, good. Okay, sweet. Let's come back to that. So again, still worrying about positioning and stuff. If we kind of look in our horizontally aligned widgets, there's some space between a few of them. And in order to create that space between some widgets, there's a widget called spacer, which just separates them. If it's in a row, it nudges them to the side. If it's in a column, it creates the vertical space. I could add this spacer at the start, and it would nudge all of them to the end. I could stick it at the end, and it would nudge them all to the start. But if that was the effect you were trying to achieve, there's other ways of doing that. For now, we just need to worry about the spacer being there. And actually, a similar thing is going on here as well. These two bits of text look like they're more so just floating at the top, but then something is nudging this row down to the bottom. So we're going to add another spacer in here. Cool. Sorry, yeah, the code is also automatically formatting itself. I'm using a shortcut to do that just so it is consistent. Dart that allows for trailing commas in things like arrays and properties. So if something doesn't look how you might want to format it, you can just add a column and quite simply it will make it look a bit different. I quite like things looking like this, so it's a bit more clearer. Okay, cool. Let's change the style of the text. So on our text widgets, they have a property. They have several properties, such as direction, scale factor, overflow, locale as well. But one we want to worry about here is style. And text style, if we hover over it, is a type called text style. And this is, you probably guessed it, how we change the style of the text. So we can give it colors. We can give it font sizes. I believe that's 20. Yep, and we can also give it font weights. Font weight is an enum in Flutter. It's got bold, normal. It doesn't have light. I do think that's something it's missing. But then it also has all the different weights, much how it does in web dev. So I'll set that to bold. Cool. You can also specify the font family if you want as well. I'm not doing fonts in this, but they are pretty much just as simple as including the font files somewhere in your project, specifying them in your pub spec, and then start using them by specifying the font family. Cool, so that's that bit of text done. I'm just going to copy this text style and use it for the next one. Also, as you can see, I'm just hitting save and the changes are being reflected instantly, which is really awesome. It just makes for building up UIs so much faster. And you've probably also noticed everything is code first. There aren't any storyboards or WYSIWYG editors. There's no dragging and dropping. It's all code. So you know, that's how all devs like to.
Can I ask a question?
Yeah, sure.
So you've specified the same text style in two separate places.
I have, yes, that's bad practice if I was going to do that, yeah.
Oh, right, okay, so there is a way to like use a class or whatever.
Yeah, so coming from web dev, it's, there isn't kind of strictly classes. Where you would specify kind of global text styles is over here on this theme data property. You have text theme, and that is a text theme class. And on here, it's got loads of different typical styles of text that you might have, such as headline, well, loads of different headlines, loads of different bodies, subheaders, this kind of stuff. You can reference some styles here. So let's do the headline one. And, oh, sorry, that's me pasting and it's done it awkwardly. But if we specified headline one here, over in our task row, we can specify, oh, blimey, this is testing me. Text theme. I'm just going to write this line and then explain what it's doing. So you've seen no visual difference. I'm also just going to remove that so you can see visual difference. What this line is doing, whenever you see a dot of context, whenever you see this, what this is doing is looking up the widget tree to find the class you've specified. So it's trying to find the theme. If I show you the tree again, a widget down here, such as text, is looking up the tree and it goes up until it finds the type it's looking of, such as theme. Theme is residing somewhere in Material Lab. And we'll see a similar line of code to this when we come to navigation. So that's how you can do things like that. If you also wanted to, you could create I don't know, like a text styles class, text styles file, and stick a load in there if you wanted to as well. There's loads of different ways, and it kind of depends on what you consider to be a cleanly architected project.
Okay, thanks.
That's okay. But yeah, so we'll roll with that. Let's change the font weight of this. So this is where I would quite like the light font weight option, but instead I just have to use the value. It does then tell you what it is here. So let's set that as light. Cool. We'll leave that for now. Now let's come to these kind of profile pictures. There's a cool widget we can use. There's loads of cool widgets. And this one is called a circle avatar. A circle avatar takes a background image, and this image can be taken from anywhere. It can be taken from in memory, it can be taken from assets, or it can be taken from the internet. There's a way to get it from the internet by using network image and just giving it a URL. And this will go ahead and place that image in this circle avatar. So it makes getting images from places just incredibly easy. If you're going to do this natively, You know, it is a bit easier nowadays, but it's still not to an extent, unless you're using other libraries, not as simple as pasting a URL and hitting save and seeing it load straight there, which is really cool. So I've got a few of those that I made earlier, which I'm going to paste in. Then, so yeah, that's loaded those in, so they're all looking good. Then lastly for this row, we've got this kind of, I'm going to call it a status chip. So yeah, demonstrating ongoing, finished, that's basically a status. So yeah.
When you build and deploy, does it drag those images in and add them to the build, or will it still be accessed?
Sorry, Paul, could you repeat that?
Yeah, so the images, the URLs you've got there, does it, when it does the build, does it drag them into their static, or does it still access them from the internet when the app's live?
Here it accesses them from the internet. If you wanted to, you can include them as assets. So quite typically, there will be a assets folder which you can stick images that you want always available in your app in here, and specify them in the pub spec. Then you can get them using asset image. Yeah, asset image, and you give it a name. Cool. There's a library called cached network image, which the first time it runs, well, yeah, it caches it. So it gets it from the network, but caches.
Thank you.
Cool, that's all right. Cool, so this chip does, I might have to speed up the pace a bit, but it's mostly doing stuff that you have seen, sticking widgets inside widgets. But cool, so this text, it needs a background color. Text doesn't by default have that. So to apply that, we wrap text in a container, which, as I said earlier, is basically just a div. If it doesn't have anything to render, it won't bother rendering. And if you don't apply any styles to it, it appears like nothing's changed. So you probably saw nothing appeared to change here. But we now can start using some of the containers properties. And it's got a few, it's got a handful. So we can specify things like color, stop, white. And we can also specify padding as well, because here it kind of looks like there is some padding going on for the container, vertically and horizontally. So let's look at padding. Padding in Flutter uses this idea of edge insets, and there's different types that you can create edge insets. You can specify the same value for all sides, say top, right, bottom, left. So if I say that 16, it applies 16 padding on all sides. If we do, we can do from left, top, right, bottom. Personally, I think that one should follow suit with web of being top, right, bottom, left, but it doesn't, but we can do that. We can then use named properties to only specify ones we want and not worry about others. So I've only applied it to the top. Or there's a neat one called symmetric, and that lets you apply some vertical padding. So the same for top and bottom, and horizontal padding as well. So 20 there. Cool, that's starting to get there. The last thing we need to do really is this border radius. So container doesn't directly have a border radius property to change, but it does have a decoration property, and this we give a box decoration. Decoration is by default an abstract class, so we do need the right implementation, yeah, typically you'll end up using box decoration. I'm going to hit save, and you're going to see the first and luckily only error in this talk. But yeah, it'll just be interesting for you guys to see what a Flutter error looks like. It's a horrible red screen and probably some hazard tape. Over the years, Flutter has been dramatically improving its error messages. So we can identify the issue here. It's saying that we cannot provide both a color and a decoration to our container, which is what we've actually done. You can then also see where in the debug console here where it's done that. So I'm just going to remove the color and move it to box decoration, because we can specify color on box decoration. And now that's happy days again. Now we're going to do border radius. And border radius, again, we just specify border radius, and the type we want it to be circular. Radius and borders are a funny thing in Flutter to get your head around, but luckily just doing a border radius is quite simple. So we can specify that to 10, which doesn't quite look enough, so we'll make that 20, and that looks quite good, although we need to change the text to ongoing. Cool, that's starting to look okay. The last things are all things that we've done before. I'm just going to quickly whiz through them because we are running out of time. So I'm going to give the entire task row some box decoration. So I can then start specifying things like the border radius. And I think that's 10. And then also things like a gradient. So gradient, I think Phil, you looked at gradients last week. And there's different types of gradients, such as a linear gradient, radial gradient, circular gradients, loads of different types. You just give it, oh, that's made stuff funny. You just give it your list of colors. So colors dots like that. And this just creates a nice linear gradient for us. It's not using the exact values. I do have those here though, so I'm just going to paste them in. Cool, that's looking quite nice. I'm now going to apply some padding to the container because we've still got a spacing issue up here and a tiny bit around the other three sides. So that's 420, 4 and 4. Cool, and then lastly, we just need to apply a tiny bit of spacing between these two texts. For something where you're only applying it to one place, it's not quite that feasible to wrap one of these texts in a container to apply padding. Or you can actually apply padding, access a padding widget directly. But quite typically, we would use a sized box, which simply takes a width and a height, and optionally a child. But we can just specify a height or a width, and that just adds some spacing for us. Cool, that's looking quite good. Last thing we're going to do, while we've applied padding to the container, we also want to apply some margin to it as well. Padding and margin are the same type, edge inserts. I'm just going to give this 8. There we go, that's looking quite nice. Cool. I'm going to come back to the home screen, and the home screen. And we could, because we're in a column, we could have loads of different task rows. Oh yeah, if your UI is overflowing the screen, that's when you see the hesitate. We could set at the number of task rows that we need, but it's not efficient to do this. It's actually much more efficient to use a list view. And again, there's two types of list views. The non-efficient way, where you have to already build the components, which uses up memory, before they're actually displayed. Or you can use a list view builder, which only builds the widgets that it needs on screen and just slightly on and off screen, which is cool. So it takes a property called item builder, which is a function, and this can be anonymous. And it has two arguments. This build context, which basically just contains information about where this widget currently is in the tree, and the index that it's currently building. So again, this was something that Phil and Paul demonstrated last week. We can have a infinitely scrolling list view. And if Phil was still scrolling as he said he was going to last week, he should be able to prove that it is pretty much infinite, as large as the Dart's integer value goes to.
It's a good point. How far have you got, Philip?
Yeah, pretty far. I've got lots of numbers. I have the best numbers.
Can we see a screenshot, or can you point your camera at your phone, or?
I think my camera's sort of broken at the moment. Yeah, I don't think that's going to work. Sorry.
Well, just a quick screenshot later or something. Share it with Twitter.
Yeah, I'll do that.
What's the largest Dart integer value?
That's my knowledge there. I think it is the one that starts with a 2 for, I think it is 32-bit.
Okay.
Don't quote me on that.
They signed or unassigned?
Unsigned.
Cool.
Unsigned.
Yeah, pretty big then. But not
Yeah. Yeah, again, don't quote me on that. Do double check. But cool. So I've replaced that text with a task row. So we now have a infinitely scrolling list of task rows. But it's really efficient because it's only actually rendering 1, 2, 3, 4, and then probably one off screen in either end. So it's actually only rendering 6, but we can infinitely scroll them, which is really cool. I can't quite. Can I press that? Actually, it doesn't matter where I am in the list. It does not matter where I am in the list. Go away, taskbar. Cool. So, does anyone have any major questions that they feel they want answering at this stage, or are they happy for me to go straight into navigation? Again, I can't see the chat. Alex,
sorry, yeah, no questions so far. And
Cool.
is anyone pushed for time? Are you pushed for time, Tom?
I'm fine. I'm just yeah. I didn't want it to go over halfway because I appreciate an hour and a half is quite a long time for people.
Well, if anyone's pushed for time, speak up now. But feel free to take it at your own pace, Tom, if that's okay with everyone.
Cool. I will still aim to finish by 8:30. But yeah, cool.
Cool. No worries.
So.
Hey, Alex.
Cool. So what we're going to do is we're going to click on one of these rows and navigate to this screen here. In interest of time, I have made this screen before, so I'm just going to drag that in. It is all hard-coded with quite fixed values, but yeah, this screen is it's all hard-coded, but it's nothing fancy. It's nothing that you haven't really seen before. So what we're going to do is navigate to this screen from this list. The way Flutter handles navigation is kind of similar to web. It uses the concept of routes, and routes are pretty like you would see them in web. The easiest way to do routes is to specify your routes in advance on your app. So the app has a given set of routes. And routes is a map which has a string which you give your route name to, and so yeah, it follows web convention. So we'll call this task. And this then takes a simple function which returns the screen which we want to show for that route, and that is a task screen, which is the one I've just pulled into the project. And again, Flutter is so flexible that this can be any widget we want. This could even be text if we really wanted. It could be container, it could be whatever we want. But it makes more sense and works better if you use a scaffold. So task screen does return a scaffold. Excuse me. Cool. The next step, we need to listen to click events for when we click on one of these rows. To do that, we need to, so yeah, firstly, there are a set of default buttons which Flutter has out of the box, or we can hook onto gestures using a gesture detector. So that's what we're going to do. We're going to return a gesture detector in our list view builder. I'm doing it here because it doesn't make sense to apply the same gesture detector to our list, our task component, because it could potentially be reused elsewhere with a different wanting a different gesture. Gesture detector takes a child, much like loads of other widgets. I'm going to give this task row. And it also has loads of methods. So on double tap, force press, drags, long presses, but the ones we want is just on tap. And that's just a simple function. It could be a class method, or it could just be another unnamed function. That's what we're going to do. So I'll just do a quick print here so you can see. Actually, let's do this. This is just a tiny bit of string interpolation. String, yeah, putting values into a string.
Perfect, the right first time.
Cool, yeah, thank you. So each time I press on this in one of these, it is printing for the correct row, which is cool. So with that, quite typically, you wouldn't just be giving list view builder an infinite number of items. We would actually be giving it a count. Let's give it 3. Let's scroll up to the top for us. Yeah, you'd have a list somewhere, and the item count would be the length of the list, and you'd be in your item builder. You'd be getting an argument. You'd be getting the current item in the list using the index from somewhere and doing stuff with that. But cool. So in order to navigate,
sorry,
yeah.
Kev, just asking, that with that being a function, can it take arguments? Does it take event data, or the ontap function, sorry?
So different ones do. Ontap doesn't. Ontap is just a empty function. But other ones such as onDrag, any of the drags such as, or onPan. onPan's a good one. OnPan start and OnPan update do take some ones. So yeah, sorry, I'm not specifying types here. Drag details. This does contain things like the position it was doing, so global position in the entire app or local to its coordinate space, timestamps, this kind of stuff. So yeah, different events have different arguments. OnTap is just a very empty one, doesn't take any. Cool. So I'm going to write out the line that we need to navigate between screens and then just briefly explain it.
Can I ask a question?
Yeah, of course.
So you've thrown down lots of code in the last couple of minutes.
Yeah.
If I go to Stack Overflow and type gesture detector,
Yeah.
you know, where's the best documentation for this?
Sure. Excellent question. So Flutter has really good documentation. The docs on the website are good. They're nicely split up into stuff. For example, the widgets catalog contains all of the out-of-the-box widgets we get. So it's got all of the Cupertino ones. It's got all of some of the basic ones. It's got inputs. It's got effects. It's got interaction ones. So you've got draggable, and here's gesture detector.
Yeah.
It has a snippet of how to use it, which is really good. Describes it. This documentation is actually built into here as well. So this description here is the same description that we're seeing here, which is cool.
Oh.
And yeah, so you can see all its properties here. So if we go to on pan down, click on that. It tells you, actually, that one's not very, that one doesn't tell you a great deal, which is really annoying. But yeah, you can do, the documentation is quite good. But if you search something like that, it will take you back to where I just showed you. But then there's loads of, the Flutter community is fantastic. Because Flutter is just so open, it's very accessible. So anyone can use it. So there's loads of Medium articles, there's loads of cookbooks, there's loads of stuff on Stack Overflow.
Yeah.
So yeah.
Cool. I mean, the documentation looks as good as like MDN. So
yeah, it is really good. And they several months ago, or maybe a year ago, one of their major tasks was just making sure the documentation was up to date and written well. So cool. Yeah. So this is the one line we need in order to navigate to our other screen. What this is doing, if you remember earlier when I told you how to access a text style from up on your app, this is doing the same thing. A navigator exists somewhere down in Material app, and so therefore we're just mapping the route we're specifying with the route we specified here and what it should return. We can also pass arguments in here, but I'm not going to do that for this. We're just going to click it and navigate to this screen. I've got another infinitely scrolling list. And yeah, I can swipe to scroll back because that's the default iOS way of navigating back. Cool. That's navigation really quickly, really straightforward. I'm going to brush over alert dialogues and stuff, and I'll cover that next week. But I'd like to move on to dependencies and how Flutter and Dart deals with dependencies. So much how like with C#, you've got NuGet, or with Node.js and JavaScript, you've got npm. With Dart and Flutter, you've got the best named one, pub.dev. Sadly, nowadays, going to the pub means going to this website as opposed to going and getting a beer. But this is where you can search for any dependencies that you want. And it's really cool because you can straight away start filtering down the packages. Sorry, there is actually a distinction. Packages are Dart only code. Plugins are Flutter, is a mixture of Dart code, but then also platform-specific code in order to talk to platform-specific APIs. And yeah, you can differentiate between, just purely Dart packages and ones which are purely Flutter ones as well. Ones which are purely Dart can run in Flutter environments, but not vice versa, just because Flutter does need the communication channel to the native platform. So yeah, if we wanted to add in a dependency, which we're going to do, actually, what's that one? English words that was added in last week. This is a purely Dart package. And yeah, Pub is really cool. It has a scoring system for how healthy and how maintained the package is, and also how popular it is. So yeah, it kind of ranks it against other packages. READMEs are then also encouraged to be good. Change logs are encouraged to be up to date, as are examples, and then also how to install. The install steps are actually pretty much the same for all of them. It just tells you the dependency in the most current version. You copy it, you paste it into your pub spec under the dependency section, hit save, and by default, Visual Studio Code runs the pub get command for us. So that has gone and downloaded the package. And because this is a Dart only package, I can actually start using that straight away in code without rebuilding, which is really cool. So nouns dot, let's just do first. And is that a string? That should be a string. No, okay, maybe I lied. Maybe it does actually need to recompile. Could have sworn it hadn't. I'm on a beta version of Flutter just because there's some cool stuff that I want to show you in just a minute. Yeah, that's gonna be a problem. Okay. That should have worked. Maybe it didn't, my bad. But yeah, that's how you add a dependency. Moving on to the next section, which is looking at persistence, we will go and add in a package and actually go and use it. So looking at persistence, there are several different ones available to mobile apps. Quite typically, SQLite is most common. So there is a plugin for Flutter called SQLite. It's just a play on the name, but this wraps around the native Android and native iOS implementations for it, just with a common API, which works across both, which is cool. There's then some other, you've then also got Cloud Firestore, which is Firebase's real-time database, which is cool. So that all reacts nicely and updates the UI on the fly as soon as it changes remotely, which is really cool. But we're going to use a really simple one called Hive. Hive is a purely written in Dart, NoSQL object store, and it's very easy to use. It has a concept of boxes. You can liken that to a table, and it's just key value, really. So you have your box, you put something in the box, you get it from the box. And I'm going to demonstrate something really cool, which is available with Hive now. So I'm going to copy this dependency. I'm going to stop debugging just because clearly that didn't work out for me last time. I'm also going to just go over to their documentation and grab a Flutter specific one because, so yeah, while Hive is purely Dart, they do have some cool Flutter features which they've brought out into this Flutter app. I'm also going to drag in one more thing which I think is just really, really awesome. And let's take that off screen for a moment. Oh no, it's gone behind Zoom and oh, there we are. Cool, that is running. But yeah, so I'm just going to very quickly show you how how nice and easy some persistent stuff can be in Flutter. By no means am I saying that this is clean or that you should do it, but it's just a quick way to be able to do it. So Hive had the concept of a box. Box, and that's going to automatically import for me. I'm just going to call this my box, and it's being slow because it's rendering quite fast. Yes, I'm just going to make this available for us on this class. Again, this would be there'd be some kind of dependency injection mechanism if you were doing this properly, but I don't have time for that. Cool. And we're going to add a floating action button in quickly just to have access to this onPressed method so we can start adding stuff to the box. So we can now say, for the purposes of this, I'm just going to stick a count for the number of 2Ds we have. So count equals start my box dot get and equals count. This is okay. So yeah, I should have specified that as an int because it is dynamic, or I can say as int, or it would actually be able to infer it, but it's better to kind of use strongly typed stuff. I'm then going to increment it, and I'm going to stick it back. So I'm also actually just going to specify the default value here as 0. So each time I now press, when it's built for this device, each time I press the floating action button, it will get the count from the store and increment it by 1. There's this one more thing I need to do over in main that's required. So in the main method, we can do some, so it's telling me that I've not done something. We have to call this to this init Flutter just lets Hive resolve where on the platform it should store its files. Then I'm also just going to open that box, which is asking us to do. Put that in the box. I'm going to restart, and this then reruns this, so the box is then in fact opened. But my floating action button hasn't appeared yet, which is worrisome. There we are, that's better. Lastly, to get the cool effect going on, we're gonna Hive has this concept of a listenable, which lets you listen to a property on a box, and when it changes, it will rebuild the UI for you. So you don't need to actively go and tell Flutter, oh yeah, it's changed, rebuild. So I'm just going to copy this. I need to add an import. Annoyingly, Visual Studio Code doesn't import extension methods the right things for extension methods automatically. So that's why I just have to manually import that. Yeah, this is called a value listenable builder. And the value it's going to listen to is this.mybox.listen to, we're only storing one thing, so it can just listen to the entire box. And this builder requires a context box. And what's that last thing? Oh, I don't quite remember. Widget. Cool. So what I've now done, what I have now done is said each time that I update something on the box to rebuild this list view, I'm going to specify the count that it should be box dot. Is that going to resolve as dynamic? That's annoying. Get count. So what I've just done, I've done some slightly dirty plumbing for when the box is updated, it should render as many items in the list as I've specified there are in the box. So if I just restart that, it's not worked. I haven't copied my own code properly. Oops. Sorry, Luke, if you're on the call, can you spot what I've done wrong? Don't worry if you can't, because I can't work it out either.
I am looking. Give me a sec.
That's okay.
Can you output? Can you print the contents of your box to the debug console?
Yeah, that is a good idea.
Or put a breakpoint as well on the return list view builder.
Yeah, that'd be a good idea. Cool. My box. Why has it not got anything? Yeah, that's not
It's
good.
never necessarily been initialized with a value, because I see you've put default value 0 on the on-pressed as opposed to. So
Yeah.
I think it's constructing item builder with an item count of null, which is probably going to do infinite, right?
Oh yeah, you're probably right there. You are right. Yeah, thank you, Luke. Cool. Sorry about that, guys. So yeah, so each time the kind of data store is being updated, the UI is reactively being updated. So I press this, and it's created a new one, which is really cool. And yeah, I can restart, and that finally will persist. So I've pretty much covered everything I want to cover, apart from alert dialogues, and I apologise that the last bit was a touch rushed. The last really cool thing with Flutter, which I want to show you, and it's actually been going on in the background since I last hit stop and play. You can actually have multiple debug sessions going on different devices across platforms. So over here, I've got an iPhone 8, I've got an iPhone 11 Pro, which is different screen size, and a Android emulator going on. I'm just going to restart these properly, and that. So now these are all, oh yeah, if I change that to default, these are all attached to the same code. So each time my code changes, it changes across both of them. So you can now, you don't need to stop and start debugging for the different platform. You can start making changes and see that reflected on all of your connected devices at the same time. If I just go and do another quick, dirty, obvious change. So I'm going to change this QPO text to text, hit save, and it's applied across all of them without needing to stop and restart. So that's a really cool way how Flutter can make mobile development just so much more productive, because there's far less stopping, debugging, and recompiling, which is really cool. And it is in a very stable state right now that I could add in that web project back and start having this exact same thing shown in the web, which is really cool. So that might be something which I'll show at the start of my talk next week. But that is pretty much everything that I wanted to cover this week. I hope you've been able to see how Flutter is different and why that's actually a good thing, and how the tools that Flutter gives you and the way just the way it functions can actually make mobile development not as painful as it used to be, and a lot more closer to this. I get to hit save, and I don't need to wait and recompile, and stuff renders as it should render. So yeah, cool.
Very nice.
Thank you very much. Do people have questions?
I have a question.
Amazing. There is just one question in chat that I haven't managed to get through to you yet, so if you don't mind. The question I've just lost again. Can you stack navigation? So can you go from screen A to screen B and then back to screen A whilst maintaining the state?
Yes, you can. So you can, there are, how should I do this? Let's do this. Yeah, I'm just going to really quickly make another widget. And yeah, there is a navigator widget. So you can enable sub-navigation. So for example, what's a good example? Bottom navigation bars, for example. Take an app like this. There is kind of sub-navigation within, sorry, I hope you can see that well, but yeah, bottom navigation bars. You can switch between these and then start navigating deep into this tab, which is My Listings, and then switch between tabs. And you can then also throw something over the top. So yeah, you can have nested navigation. So yeah, one level of navigation is fine by default. 2 levels, again, is still fine. When you start to have more than 2 levels, you need to make sure that you're keeping track of which navigation level you are dealing with. But yes, you absolutely can.
Cool, thank you.
Sorry?
Philip, you had a question about persistency, I think?
Yeah, hi. So with that Hive stuff looks really good. If the app gets switched off or the phone gets restarted, will it reset to the default value? How persistent is it?
It is a persistent store. So yeah, it's if you restart the phone, whatever, it stays there. This default value property is for if this is the first time the app is run, and that this property just does not exist. But yeah, it completely persists. So that's yeah, much how like SQLites will as well.
Or local storage in the browser.
Yep, local storage in the browser. I'm pretty sure Hive on Flutter for web does use local storage in the browser. It definitely uses one of them, but yeah, that's available straight away as well, which is really damn cool. So yeah.
Another question on widget testing. So I was going to ask about end-to-end testing with widgets, if you've got time. Unless you're going to cover testing next week, possibly.
Again, testing probably isn't something that I'd cover next week. It'll probably it'd probably kind of be its own talk. But yeah, so Flutter there's 3 different types of tests you can do with Flutter: unit testing, widget testing, and then full-on end-to-end integration testing. So unit testing is like any other language. You're testing units of code. Widget testing is then actually testing, well, it kind of says it, individual widgets, and it can actually be at any level. You can test a home screen, so you can test, when I've got a home screen, there should be a floating action button. And if I press this floating action button, some text should now be available on the screen. So that's kind of like a nice medium between the power of integration testing, but then the ease of writing and running unit tests. Because widget testing uses a headless version of Flutter, which just runs, well, actually, this here is a widget test. Let me just stop all of these. And if I run these tests, actually these are gonna fail because it's expecting some widgets. So yeah, you can see here, it's expecting to find some text 0, and it's not expecting to find 1. But then it's when we say on my app, when I tap an icon, which is icon add, and wait for a frame, it should be the opposite. 0 shouldn't be there, but 1 should be there. And this is all headless, and it is running slow. That's because I've got like 3 simulators open, and my laptop's actually becoming unresponsive. But yeah, so yeah, you can do widget tests, which are actually a really nice medium between doing full-blown integration tests. You can also do integration tests with Flutter as well. But yeah, testing I could easily do a whole talk on. yeah, widgets.
Definitely.
Yes, please. Can we have a whole talk on testing?
Yes, Paul. We'll do a completely clean architecture one for you.
Because you know me, I don't really like testing that much.
No, yeah, testing's important, and yeah, also has built-in code coverage as well, which is cool. So yeah, if people are still around, I have actually just I have actually just re-added in the web project. So because I'm on a beta branch, I do have access to the web project. It's not yet available in stable, but the moment it is, in a Flutter project, you can just run the Flutter create command with a full stop inside your current Flutter projects directory, and it will then add in the web projects for you. And that's then when Chrome becomes a build target. So I can now start debug. Oh no, God, that's doing them all. It's doing them all. Stop looking for my machine.
Flames just appear in front of the video.
Yeah. But yeah, so that's now launching in. It's now, well, it's actually quite fast, which is nice. I don't know if I had Chrome open, but but yeah. So once that's available,
Code be available for this project after the talk.
yeah, but it will be. I'll
Awesome.
put it to a repository straight away.
Yeah, sweet. We'll put it on a comment on the meetup or something on the event.
Yeah, that'd be good. Cool. Here we are.
Awesome.
It's
Oh my god.
oh my god, the holy grail of write once, run anywhere, and it actually
Wow.
amazing. So yeah,
No way.
yeah. It's
Can I have a look at
Holy grail
DevTools?
right there.
Can I have a look at DevTools?
How many elements are there?
Yeah.
yeah. So let me just add that. Wait, let's place it. So it's looking quite neat at the moment, but then when we start diving down into here, it does then it's using sorry, excuse me. It uses a lot of its own stuff. It does use some, native HTML elements. Like, is actually going to let me inspect that? Not really. There's a whole Flutter widget inspector, which I did actually forget to show. And that's where you can start inspecting stuff. But yeah, Flutter for Web, again, it is still in preview, but it is still really good. It uses native web elements where it can, but where it can't, it uses different canvas renderers. But yeah, so these are the Dart dev tools. And when you're running Flutter, you can click on, you can inspect your entire tree. You can even turn on select widget mode, which I'm actually surprised works in web at the moment. So, okay, I say works. I should have demonstrated
I saw that work.
Yeah, cool. Yeah, so you can inspect the entire widget tree. You can turn on debug painting, which definitely does not work on web. I'm not going to do that anymore. You can then do some, the screen doesn't work. I chose the wrong time to demonstrate this to you. But yeah, that was good.
That's why it's in beta. That's still really awesome.
It's still streets ahead of React Native, right? Let's be honest.
Yeah, I've been very careful just to not compare Flutter to other frameworks by using words like good or better. I've always used different because people do need to make up their own minds about it, and it is a different approach. Again, it still might not fit with everyone, but it has dramatically pushed forward this concept of write once, run anywhere. It's so good already, and if you wanted to completely bypass the app stores, you could write an app in Flutter and have it as a progressive web app. Of course, you wouldn't get access to absolutely everything you can with a native app, but there you go. It's gonna work well. So yeah.
Thank you. That's been really good. That's
Cool.
amazing.
Yeah, it's very interesting.
Cool. I'm glad you guys found it useful.
So
Can we
much.
have a small round of applause?
Yeah.
Tom, thank you very much, Tom. That was
Right. Thank
really,
you.
yeah, that was amazing.
Yeah,
Really,
cool.
really,
Yeah.
really good.
Yeah, that's so. Yeah, next I have another session next week, same time, same place.
14th of May, yeah.
Yeah, and I will myself and Luke, who I've been working with for the past 6-7 months.
Hello.
We're gonna double team it. We're gonna build upon this. I'll probably clean this up a bit nicer so everyone can have access to the same code if they do want to follow along, and we'll build up from there. So we'll cover things like alert dialogues, and then doing more with passing data through the app, because statically hard-coded data isn't very great. But yeah, so yeah, do come along if you want to learn a bit more. Then yeah, if there's more interest after that, of course we'll do another. And yes, Paul, if more people want your completely testing only session, we'll do that as well.
It's mine now, is it? Right, in that case, I'm going to tell you exactly what I want you to do.
That's what I was doing.
If it has a slight teacup at the top and a blue brand, be on caution, Tom. You might be furthering Paul's own projects.
With a controversial magnifying glass logo.
With a controversial, nice.
It's purple, mate, not blue.
Right, well, yeah, thanks again, Tom. Thank you very much. Again, 14th for the follow-up. Pleasure to see everybody here again. Thanks, everyone. And yeah, I shall end it here. There should be a YouTube video to catch up afterwards as well, if I can get my Linux laptop to play ball with video editing. And then we'll be, yeah, great. See you, Luke and Tom, next week.
Cheers.
Nice one.
Cool. Cheers, everyone. Thanks for coming.
See you later.
Cheers,
Bye-bye.
guys.